we talked about hypothesis testing, and we talked about claims and the opposite, H sub 0 and H sub 1, no hypothesis and alternative hypothesis. We talked about test statistics. We talked about left and right tail tests. And what else? And we talked about how we can check if we reject the test statistics, the null hypothesis based on our test statistics or not. Now, there is the method we've been using to test the hypothesis is called the traditional method. And there is a second method called the p-value. Sometimes referred to as the observed sometimes referred to as the observed significance level. And p-value works in a very similar fashion for the first couple of steps. You still have to state the claim, you still have to state the opposite, you still have to state H sub 0 and H sub 1, you still have to calculate the test statistic. But the moment you calculate the test statistic, you find the probability for that test statistic. Let's do an example. On that extra sheet of problems, let's do problem number 1. Yeah, let's do problem number 1. So, problem number 1 states the following. Let's put this. It states H sub 0 is defined as mu equals to 4.8. What's H sub A? It says H sub A here.
1.
Yeah, it's H sub 1. We define it as H sub 1. Here's defined as H sub A. It's the alternative hypothesis. H sub 1 is defined as mu not equal to 4.8. N equals to 50. X bar equals to 3.6. And S equals to 0.4. So this is what the problem states. On an exam, you are going to get an actual sentence, because the translation from sentence to mathematics is important to me. But this is what you get here on this problem set. And so the question 1 says, find the test statistic. Given that the samples are drawn from a normal distribution. So what's the test statistic? Well, what test statistics do we have? We have p hat minus p divided by pq divided by n under square root. We have that as a test statistic, right? We had this test statistic. We have x bar minus mu divided by sigma square root of n. Yes? We had that tested. And then we have the last one, we had that one. Right, those are our 3 test statistics. So which one are we using?
The middle one. No, the last.
Oh, you both are right. How big is the sample? T refers to small sample sizes, right? This is large. This is saying, hey, central limit theorem is going to kick in, right? So we would expect this to be the middle one. The problem with the middle one is we don't know sigma, right? But because the sample is large, right, we know that with large samples, T and Z become very, very similar. Yes? Right. We don't have sigma, so what we can do is we can say, hey, this is about that. Right? Because we are close enough. We took a big enough sample. Right? Okay, great. So let's plug it in. So what do we get? Well, we get 3.6 minus 4.8 divided by 0.4 divided by square root of 50.
C.
1, 2, I think. 2, 1. So we got negative 21.21.
Can you give us time to figure it out on our own?
Yeah.
I think that's part of the problem is when you give us an answer,
You stop
you
typing.
stop talking.
Yeah.
Okay?
Yeah.
For the other 7, I'm going to sit back and relax. Any of you forgot your calculator? Which one do you usually normally use? The smaller one or the bigger one?
The smaller one.
I'm going to toss it. Did you get something like I did? Why not?
I had to do the calculation. That's what it is.
Try putting it in the following fashion. Try plugging it this way. If you plug it this way, it should work. So this enter times this enter divided by this enter. Yes?
Yeah. Yes.
Yes. Excellent. Okay. Right, so we got part 1 done. Now, if we did the traditional method, the method that we've been using so far, we would flip over and approach question 17. So part 2 of the question. Part 2 of the question says, hey, if alpha equals to 0.05, do we reject h sub 0? Can we accept h sub 0? Can we ever accept h sub 0?
No, it can't be 0.
You cannot accept h sub 0. You cannot accept it because you can only reject it. Right? We could accept it if we performed a census, and nobody is going to, in the right mind, perform a census. Right? So we can only reject it. So the question is, do we reject it? In our traditional way, the way we've been doing it, at this point we drew a picture. Right? We had to decide if it's a left, right, or two-tail test. Since we assume that this is a true statement about the population, right? That's the assumption of the true statement about population. What we are using to determine if it's a left, right, or two-tail test is this. And this is a two-tail test. One tail, left or right? Two-tail test, right? This is saying, hey, not equal. So it's either smaller or bigger. So in our case, is this. Okay, so where can I find alpha? Yeah, where's alpha on this picture? Both sides together are alpha, right? And because this is a symmetric picture, both sides are alpha over 2. Well, half of this is 0.025. 0.025. So the next step was, after we found alpha, was to find the critical values. Right? The value that separates the reject region from the fail to reject. This is the fail to reject.
How do you get 0.2?
Half. Alpha over 2. Alpha over 2 is an actual fraction. Alright, so we pull up the z-score table and we look for those two numbers. Which one? Both of them?
Both.
No?
Left one's
Negative.
negative.
1.96. Okay. All right. So now we have our critical values. So what's the last step? The last step is we're going to look where the test statistics is going to end up. So our test statistic, which is this one, where does it end up on our picture?
Way left.
Somewhere around here. Which means, what conclusion do we draw? If a test statistics falls into reject region, we reject H sub 0.
So we prove H1.
So we say, hey, maybe let's do it differently. Let's go. Right? And the last step would be to actually write it in a sentence, but because we don't start with a sentence, we don't have a sentence to write. So we reject H sub 0.
But do we say we don't have enough evidence, or do we have evidence?
The problem is you don't have a statement. You don't know which one is the claim, which one is the opposite. So in this case, we would say, hey, we have enough evidence, and depending if it was the claim, to reject the claim. If it was the opposite, we say to support the claim. Because we don't have a sentence here, we cannot produce a sentence in the end. Right? But we reject H sub 0 because the test statistic fell into the rejection region, which is dictated by a two-tail test and an alpha of 0.05. Okay, so that's the traditional method. Now let's look at the p-value.
Oh, before you go on, can I have a question?
Sure.
Number one, the information that you gave us on number one,
Yeah?
there is no 0.05 as in the alpha. That information is left out.
17. Look at question 17. On the other side.
I thought we were doing number one.
Yes, but we're doing 17, part 2.
Oh,
Question 1 is here.
oh,
That's question 17.
okay.
Too fast?
No, no,
No, look, if I didn't say 17.
I didn't hear it.
All right. So this is the traditional method. Now, p-value method works slightly differently. P-value says, hey, we're going to compare the observed significance to what? or to the significance that is given to us, right? That's the significance level. So we're going to compare the observed significance to this. How do we get observed significance? Is we're going to take the test statistic, and we're going to compare it to a probability, a p-value. This probability is called the p-value. And then we're going to compare our p-value against alpha. There are two outcomes we can have. If p-value is less than alpha, we reject h sub 0. If p-value is greater than alpha, we fail to reject. Okay? Those are the two outcomes. Now, greater or equal. Exactly. Okay. So that's part one of this. Part two of this is how do we get p-value probability from our test statistic? Our test statistics came out to be negative 21.21. What's the probability associated with that? How rare? 99.9999999 or 0.000000001. This is a negative. So the probability associated with this, is, so if we take, that gives us a probability of right? There's a bunch of zeros. There should be, I think, 28 zeros altogether, 29 zeros. But for argument's sake, we get this, right? We compare this p-value, to alpha. How much is alpha? There's one more little caveat. One more little caveat is this is a two-tail test. If we are talking about a two-tail test, means we can have a significance on left and the right side, which means you have to double the p-value, which is still extremely small. Right? Because this is a two-tail test, so because this is a two-tail test, we have to compare the p-value times 2, right? In the traditional one, right, we looked at the alpha over 2, in the p-value, we just double the p-value. Okay, so let's double something that is really, really small. If we double something that is really, really small, right? What do we get?
If we double the p-value,
Yeah.
it still would be like 0.00.
0.000 instead of 1 or 2, right? Which means that even doubled, p-value is way smaller than alpha. If p-value is way smaller than alpha, we reject h sub 0. It's a different way to check things. Are we okay with that? There's two ways to do it. One is you take the test statistics and you compare it to a critical value. The other one is you take the observed significance and you compare it to the significance level that is given to you in the question. Now, which way you decide to solve problems is up to you. I like traditional better because it resonates better with me. I like z-scores better than probabilities, but certain people find probabilities better. You should be able to do both. Okay? All right, so knowing this much about the p-value, let's try problem number 9. Problem number 9 says, find p-value for question 1. What is the p-value for question 1? Anybody?
Did we already find that?
Oh, we found this.
Yeah, that's the p-value.
Well, but look at it, it's a multiple choice question.
Is that 0?
Yes, it's 0. It's so small, we're going to round it to a 0, right? Again, I stole the questions from somebody else, so somebody else says 0, I would say approximately 0, or about 0. I would never say 0, because even with a z-score of negative 21.21, the probability is not 0. Yeah, I have a better chance of walking to the sun and moonwalking back than this, but you know, I keep my open mind. All right, we're good on how to get p-values? Questions, comments, concerns? All right, well, there's 7 other problems with p-values, with questions about hypothesis, so let's do this. Today we're doing problems. I want you guys to be like this on hypothesis testing. And then Monday we're going to do some other stuff. I have plans. I have great plans for you. Hypothesis testing, because this section is the last major testable section for the final. There will be a little bit, maybe a question, maybe half a question here and there of other stuff that we might cover after this, but hypothesis testing is the last major questionable thing that I can put on the exam.
We have 12 questions, right?
There will be about 12 questions, maybe a little bit more, maybe a little bit less, maybe there will be a couple sections, but yeah. Yes?
How did you get the probability mean?
I looked at the z-score and I looked at the z-table. If I look at the z-table goes to negative 3.5. I think your table goes to negative 3.5. And then negative 3.5, it's 0.0001, I believe. Yes? Right, that's the smallest value you have there. Right? This is way smaller, so I put a couple extra zeros here just to signify that it's way smaller.
Okay.
Yeah. Just like if you had a z-score above 3.5, then I would put 99999, and I would put a couple extra 9s just to signify that this is way bigger.